I am the Tofu Golem. Please enjoy the video.
You start by ensuring the GPU stack is usable. Install the vendor driver and matching CUDA or ROCm toolkit, then add the libraries to path. Once done, install framework packages with GPU support, for example, Torch with CUDA binaries or TensorFlow GPU. Next, reboot if required and run NVIDIA SMI or RICMINFO to confirm the card is visible. Make sure the framework reports the device, e.g., Torch, CUDA, is available, returns true, before proceeding to code changes. Now modify your code to target the GPU. Set device equals Torch, device, CUDA, or the framework equivalent, and move the model and all tensors to that device. Once done, adjust batch size and data loader settings. Pin memory equals true and more workers to keep the GPU fed. Use mixed precision, AMP/FP16, to speed up compute and reduce memory, but validate numerical stability. Also make sure optimizer state lives on the device, and that checkpoints save device-aware parameters. You're ready to run training or inference on the GPU. Start the job and continuously monitor utilization via NVIDIA SMI or a profiler to ensure compute and memory are used efficiently. Make sure to save checkpoints at intervals and use gradient accumulation when batch size is constrained. If a run fails, check for driver, toolkit, and framework version mismatches and review memory usage for leaks. Often upgrading or rolling back CUDA/CUDN to a compatible version fixes incompatibility. Finally, iterate on batch size and precision to
Thanks for watching. Consider subscribing if we helped you today.